Bismillah ar-Rahman ar-Rahim. We will start discussing vectors, and this is very important at the beginning of the course to describe vectors and how we represent vectors and how do we deal with them mathematically. First of all, let me remind you of what we mean by a vector quantity. Vector quantity is the physical quantity which is fully described when we give its magnitude and give its direction. This is in contrast with the scalar quantity, which is fully defined by its magnitude only. Let me start by telling you what are the different ways of representing vectors. Okay, so vectors can be represented in different ways. The first way is by giving the magnitude and direction. Let me explain this more. If I tell you that a vector, a force vector, is having a magnitude of 5, and it makes an angle theta with respect to the positive x-axis. So let me draw this. This is the positive y, and this is positive x, positive y, and let me assume that this is my vector. I call it vector f, so we're presented with a certain length. The length represents the magnitude, and this little arrow tells the direction. And this vector f makes an angle theta with the positive x-axis measured in the counterclockwise direction. So this is the counterclockwise direction. We move from the positive x-axis an amount theta. We reach our vector f, which has a magnitude equivalent to the length of this line drawn to a certain length. Okay, so if we assume that each 1 centimeter represents 1 Newton force, so 1, 2, 3, 4, 5. So this is 5 Newtons. Okay, so we can write this as F magnitude. These two parallel lines, as you learned in math courses, represents the magnitude of this vector. So it is 5 Newtons. And we say that it makes an angle theta. So F makes an angle theta with respect to positive x-axis, and this is measured counterclockwise. Okay, so this is the first way of representing vectors. The second way we represent vectors by giving the components of a vector. So I'll take the same vector and try to give its components. Okay, so this is positive x, that is positive y. My vector f, the same vector. Its magnitude is 5, and it makes an angle theta with the positive x-axis counterclockwise. Okay, now we can find the projection of this force vector along the positive x-axis, okay, by drawing a line from the head of my vector perpendicular to the x-axis. Okay, so I draw it perpendicular, and from the tail of this vector until that line, this is what we call fx. So fx is equal to the projection of f along the x-axis. Okay. Similarly, we can draw a line from the head of F perpendicular to the y-axis, and this will give us the y component of my vector F. Okay, so this is x component, and that is the y component. Notice that this is Fx, which is the same as this. Okay, and this is Fy. We can also consider this as Fy. So Fy is the projection of the vector F along the y-axis. From trigonometry, we notice that the Fx is the neighbor of my angle theta. Okay, so because it is the neighbor, so Fx is the neighbor. Okay, neighbor of theta, while Fy, which is this one, so this is Fy. Okay, it is, as you can see, it is the opposite of angle theta. Okay, so here we can write Fx as the magnitude of my vector F, and because it is the neighbor of theta, so we'll use cosine theta. Fy, because it is opposite to my angle theta, this will be magnitude of F multiplied by sine theta. Okay. To elaborate on this more, we can think of another angle. Some students might prefer to give the angle this force vector makes with the positive y-axis. And you can notice that this is the angle phi, where phi is the complement of theta. So theta plus phi will give us 90 degrees. In this case, Fx is the opposite to phi. Okay, so it is opposite to angle phi, while Fy is the neighbor or the adjacent of angle phi. Okay, so this is a neighbor to angle phi. So now we can write it or express Fx and Fy using this angle phi. I would like it here. I hope it is clear. So this can be written as F. Okay, because it is opposite, so we'll use sine phi. Okay, and the y component in this case will be y component because neighbor to the angle phi, so we'll use the cosine of phi. Okay, so if we know the vector, we can find its components, or if we give the components of a vector, we are fully describing the vector. If you know the x component of a vector, you know its y component, we can find its magnitude. Okay, so the magnitude of a vector, which you are given its x component and y component, can be found using Pythagoras. Okay, here you have Fx, Fy, this angle is 90 degrees, so we can find this length is the square root of Fx square plus Fy square. Also, if you are given the components of a vector Fx and Fy, you can find the angle it makes with the positive x-axis measured counterclockwise. In this case, it will be tan inverse of the y component divided by the x component. So we can switch from this representation easily to that representation, and we can move from this representation to this representation. Okay. Now, would like to make our life simpler, and we make another third representation, which is called the unit vector notation representation. Okay, let me do it on this side. So number 3 is the unit vector notation. Let me start by defining what we mean by unit vector. Unit vector is any vector which has a magnitude of 1. Okay, so any vector with a magnitude of 1 unit is called a unit vector. So any vector in any direction which has a magnitude of 1, we give it the name unit vector. Okay, so as you might guess, we have infinite number of unit vectors, but we'll focus on 3 very important unit vectors. Okay, those unit vectors are I unit vector, j unit vector, and the k unit vector. What is the I unit vector? It is a unit vector along positive x-axis. Okay, so the positive x-axis unit vector, we give it a special name. The name of that vector is I. So when you see I vector, you should have in your mind, oh, this vector has a magnitude of 1 and its direction is the positive x-axis. Okay, what is j? Similarly, it is a unit vector, but now it is along the positive y-axis. Wherever you see the vector, this symbol j, it tells you that this is a vector, has a magnitude of 1, its direction is the positive y-axis. Okay, the third unit vector, or the third famous unit vector, is the k unit vector. It is a unit vector along the positive z-axis. So when you see k unit vector anywhere, it is a vector with magnitude of 1 in the direction of the positive z-axis. Let me draw this for you and see how we can utilize this to represent our vectors in an easy manner. Okay, so this is my positive y, this is positive x, okay, and this is positive z-axis. So this is in the space, 3 dimension. Okay, so along the positive x, let us assume 1 centimeter is 1 unit. So this is the unit vector I. Okay, this is the unit vector j, and this is the unit vector k. If I have a vector f, which is having 2 components, fx of this vector, for example, it has 4 units. Okay, while fy is 3 units. Okay, so if I want to draw it here, fx, so this is 1, this is 2, 3, 4. So I can draw my fx as this. Okay, so this is fx. As you can see here, fx is 4 times the unit vector. Okay, 4 units. 1, 2. This is 3. Sorry. So it is 4 units. Yes. Okay. Let me repeat it. So my force vector, which was given in step number 2 there, it has, let us assume it has 4 units along the positive x-axis, okay, and it has 3 units along the positive y-axis. So this is basically fx, okay, it has a magnitude of 4 in the positive x direction. So I can write fx as 4i. Okay. Similarly, I can write this 1, 2, 3. So this is my fy. Okay, so this is fy. So fy is nothing but 3j. 3j. So I can write my vector, in this case, my vector f, simply, without talking too much. F is simply 4i plus 3j. And I say that this is the force vector. You might give also the units. It is given units of newtons. When you see the vector written like this, immediately you will know this vector has 4 units along the positive x-axis, and also it has 3 units along the positive y-axis. If we want to find what is the magnitude of this vector, okay, so f magnitude will be square root of the x component squared, which is 4 squared, the y component squared, which is 3 squared, and this will be 5 newtons. And if we would like to know what is the angle theta it makes with the positive x-axis measured counterclockwise, this will be tan inverse of the y component divided by the x component. And this is, if you calculate it, it will be 37 degrees. Thank you.